Everyone, will discuss about the combustion. In the current lecture regarding the topic combustion, few things I'd like to discuss. What is the combustion? Combustible substances, non-combustible substances, their examples. Example of the process of combustion: ignition temperature, calorific value, and some scientific reasons related to the combustion, ignition temperature, why some things occurs in our day-to-day life. So the reason is hidden in the process of combustion as well as ignition temperature. Then matchstick, how it works, forest fire, constituents of matchstick. Okay, all that basic things we'll discuss. So let's begin. First of all, what is the name of the topic is combustion. Okay, here I like I'll write here combustion, and after that let's start the content. The first thing in the topic, let me tell you, as per the ability to get burnt, as per the ability to get combusted, the substances are of the two type. What are the types of substances? Okay, we are considering the ability to get combusted. So the substances are either combustible substance and non-combustible substances. Non-combustible substances, combustible substances which can burn. Okay, so these are the combustible substances which can't burn. These are the non-combustible substances. So the substances which can burn, examples are which one? Paper can burn, wood, petrol, hydrogen, methane, uh, propane, that LPG constituents, propane and butane, CNG constituents, methane, ethane. All these are the combustible substances. Okay, non-combustible substances: soil, then water, non-combustible substance; ice, non-combustible substance. Okay, many metals we can't say they are combustible, they get heated. Okay, but we can't bring the combustion, like some metals are there like sodium, magnesium, they get combusted. Okay, but iron, so had you seen that iron get can be molted at a temperature beyond 5000 1535 degrees Celsius, but non-combustible substances. Okay, non-combustible substances which can't be burned. Soil is there, rocks are there. Okay, water is there. So these are the non-combustible substances, and there are many some bridging substances. They get molted, melted, or they reach to a very high temperature. Their color is also get changed. Many things, but a broader discussion here we are doing. Now, second thing, how we can define the process of combustion? Let me tell you, the combustion is nothing but the. Please see, combustion definition I am writing here. The combustion is nothing but the process, the chemical process in which substance react with oxygen to form heat and light is called as combustion. Is called as combustion. Okay, and so you understood, say for example paper here we have, and if we keep along with the burnt matchstick, that paper start to burn. Very common phenomenon of combustion. Okay, this is the oldest chemical change which is known to the human civilization, that is the combustion. Okay, so that substance is to react with the oxygen at a certain temperature. Okay, and what happens? Heat energy, light energy is get produced. The heat energy is get produced, that substance is get burnt. Okay, it is in the form of glow, or it is in the form of the flame. Student, try to understand, whatever the heat energy is released, that is either in the form of glow or it is in the form of the flame. I'll give the example. Paper, if we bring the combustion of paper, it burns with the flame. Correct. Wood, wooden objects are get combusted and they are also producing the flame. But if we take the example of the coal, charcoal, okay, these substances are get ignited. Had you seen the flame of the coal? Okay, coal stores, some of you might know about the stores of the coal. Okay, coal is get putted and the heat energy is provided. Okay, so the it glows and heat energy is released in the form of the glow. So these are some characteristic of the combustion. And one more thing, sometime the sound energy is also get produced. Okay, sometime in the winter season wooden splinters are get burnt, so certain characteristic sound is get produced. Okay, so sometimes sound energy is also get released along with the heat and light energy. Okay, so this is about the basics of the combustion. After this, what is the meaning of the ignition temperature? Okay, ignition temperature, let's see. Here I'll write the heading: ignition temperature. Temperature, RATURE. Ignition temperature is nothing but dim. Yes, I am telling simultaneously, I am writing also. Okay, here. Okay, here. So the lowest temperature, at which substance catches fire and starts to burn is called as its ignition temperature. Okay, for example, ignition temperature of paper is 233 degrees Celsius. Of course, there are the many different varieties of the paper, but here in the book given that average value, or you may consider whatever the ordinary paper we have. So if we want to bring combustion, how much should be the temperature at its surface? Tell me, is the paper is going to burn by the energy obtained by that tube light? Okay, ordinary light is not going to bring the combustion of the paper. Yeah, we know that lens is there, and if we concentrate the radiations, solar energy, and if that solar energy is allowed to pass through the lenses and the solar energies get concentrated, and again we can bring the combustion of the paper, that's the different story. But 233 degrees Celsius, that much temperature is to be reached. So minimum temperature, okay, easy to understand. So that temperature is required. Okay, then we can bring the combustion. So now students, we need to know there are the substances which are again we can classify the substances, of course, combustible substances based on its ignition temperature. There are the some substances which are having low ignition temperature, some are having the high ignition temperature. Okay, can you give examples? Low ignition temperature. Low ignition temperature means what? Easily that substance catch a fire. Okay, for example, the gases like a hydrogen gas. Okay, then we have the natural gas, CNG. Okay, nowadays I am seeing in many places that CNG pumps are also there. You also might be noticing this one. So CNG consists of which gases? Methane, CH4, and ethane, C2H6. Methane and ethane are the constituents of the natural gas. When it is get compressed, that is the compressed natural gas. And LPG gas cylinder, household gas cylinder, which we use, okay, for the different purposes, household purposes. So that LPG consists of propane and butane. These are the constituents of the L. So these are the substances having a low ignition temperature. As soon as that lighter spark created by the lighter is adequate to bring the combustion of that LPG gas, correct? Even the substances like petrol, diesel, kerosene, they have the low ignition temperature, correct? But if we consider the substance like a coal, charcoal, cow dung, even wood, okay, logs of wood, so these substances, only matchstick is not adequate. Single matchstick, suppose if we have, and we are going to bring the combustion of coal, it's not whatever the energies get produced by the single matchstick, it is not significant so as to bring the combustion of the coal, charcoal, and wood. Okay, so high ignition temperature. Okay, so this is also one way to classify the substances. Now students, after the ignition temperature, here the classification just we discussed. Now beside this, next thing, let's discuss about the matchstick. Okay, all we are familiar with the matchstick, and very commonly, very oftenly it is used to bring the combustion. Of course, the lighter is also there, gas lighter, kerosene lighter, petrol lighter, as well as the lighter, household lighter, okay, which creates the spark. Different things are there which are used to initiate the combustion ignition. But now about the I'm talking about the matchstick. Okay, so how we can say, what we can say about the matchstick? Matchstick, it is nothing but the very short, short or very short. Okay, a short, thin stick of wood. It is a short, thin stick of wood. At one of its end, chemicals with low ignition temperature are kept or attached. Okay, apex of matchstick, all we know, blackish, little brownish colored that apex of matchstick is. So certain chemicals are get sticked. Students, do you know which chemicals are there? In old days, here I'll write old days, and here in the current days. In old days, antimony trisulfide, SbS3, antimony trisulfide, potassium chlorate, KClO3, and white phosphorus, it was in use. Okay, nowadays antimony trisulfide, potassium chlorate, and red phosphorus is in use. Red phosphorus, see, white phosphorus having very low ignition temperature, very high calorific value, and it was reasonable so as to have the different accidents during manufacturing, during handling, while in use of that matchstick made of by the white phosphorus. So nowadays we are using the red phosphorus along with this antimony trisulfide and potassium chloride. Okay, these are the major constituents of the apex of the matchstick. Okay, now students, let's see. Oh sorry, there might not be all students. Okay, so dear friends, let's see the next thing about the matchstick. That is nothing but the how matchstick is lightened. What is the mechanism? We know that, suppose here we have the matchbox. Okay, I try to sketch it something. Yes, and here there is a rough surface of the matchbox. Just imagine, this is the rough surface of the matchbox. This rough surface of the matchbox, it is having the high ignition temperature, and here we have the matchstick. Here the matchstick, it is having the low ignition temperature. So what happens when the friction is created in between? Sorry, I am not showing you practical, but all you are the familiar. Okay, I was thinking at the beginning to do something practical, but no, I hope easily. But you also don't try to do practical in normal condition. We know, ordinarily we know this mechanism. So here matchstick apex, here there is a red phosphorus and that few more chemicals, SbS3, KClO3, low ignition temperature, and here the surface, rough surface, high ignition temperature. If you make the friction, the heat energies get created, and that heat energy is adequate, okay, so as to initiate the ignition of the apex of matchstick. Are you understanding? Here, what, because of the friction, whatever the energies get produced, heat energy is generated, that heat energy is able to initiate the combustion of the matchstick, not of this matchbox, because this material having the high ignition temperature. Okay, it's an interesting one. Next one, frying pan. Say sometime what is noticed in a kitchen, frying pan, and here the oil is there, and heat energy is given little more time, and this whatever the oil is there, sometime, okay, rarely, that oil catches fire. Okay, in some videos we saw, or sometimes some of you might have seen or experienced also this one, unfortunately. So here that oil is over the pan, and if it is get overheated, so sometime that it catches the fire. What's the reason? Of course student, I am telling here, the reason is that because the ignition temperature is reached, whatever the oil is there, Okay, oil is made up of the carbon, hydrogen, okay, and little amount of the oxygen also. So that oil, its ignition temperature is reached. Atmosphere consists of the oxygen, so because of that it start to catch the fire. Okay, now students, the question is that a big log of wood, say for example big log of wood here we have, and here we have the matchstick. So matchstick can catch the fire easily, and big log of wood can't catch the fire easily. Okay, matchstick, okay, small matchstick, and it is a big log of wood. Small splinter of wood you may take, okay, or the dry grass, okay, bushes, herbs, shrub, if they get dried. So this material in dry form, herb, shrub, in the dried form can catch fire easily, but it can't. Why? Because ignition temperature is low, here the ignition temperature is high. Okay, so this is thing. Student, one thing I forgot to tell, but it is the basic, let me tell you, that is about the conditions necessary for combustion. Okay, let's see next heading, conditions necessary for combustion. What are the three requirements so as to bring the combustion? So here I'll write combustion. When the combustion is possible, there should be a three things. Okay, I'll show the arrow. Which three things are required? Let's see. The first thing which is required so as to bring the combustion is there should be a combustible matter. That combustible matter, generally we call it as a fuel, but sometimes it may not be a fuel. Okay, so say for example paper, clothes, okay, wood, or something else. So it generally it is fuel, but sometimes it may not be a fuel. Combustible matter is there. Okay, carbon, hydrogen, major constituent it may have. Okay, hydrogen H2 alone can be, is it, it's also combustible. Then there should be a presence of supporter. And what is supporter? Oxygen is supporter of combustion, all we know. And here third thing is that there should be a adequate energy. Adequate energy means that ignition temperature is to be reached. Okay, so we should say, I am asking simple question. Suppose here the paper is here. Okay, now this paper I have. Now students, why the combustion of the paper is not occurring? Because combustible matter, this paper we have, atmosphere consists of oxygen. Why combustion didn't occur? Because as adequate energy is not there at the surface. For this material, adequate energy is not there. It should reach that temperature. Okay, degree of measurement of the hotness or coldness of substance is nothing but the temperature. So adequate energy is required. So this is the requirement, basic requirement for the process of combustion. Now beside this, let's see next one, that is forest fire. Two mechanisms are given. Sometime we listen the news about somewhere the forest fire occur. So about the forest fire, yeah. The reason is that first mechanism is given. Forest fire, simply in the forest, the fire may get occurred either because of the manual reason or because of the natural reason. Manual reason, someone is doing smoking, cooking in such a forest area, okay, illegally, so that may cause the fire. Okay, electricity lines, if they are going, and if the spark is get created by them, it is also one of the reason, okay, for the creating the forest fire. Naturally what happens, big trees in hot summer days, because of the wind, these big trees, what happens, they the friction occurs in between them, and of course we know, because of the friction what will happen, because of the friction the heat energies get produced, and sometimes the spark is get created. Okay, extreme condition it is, but the spark is get created, and when that spark is get fallen over the dry grass, dry herb, dry shrub, and then slowly steadily, initially combustion started and it gets spread, and of course huge scale of the loss, life and property loss, huge scale of the loss of the biodiversity occurs. So all that things are there. So this is the one mechanism. that is trees are get friction occurs because of the wind in a hot summer days, and another many reasons just I told that electricity or manual some reasons because of which the forest fire may occur. Okay, so here also the thing is required, ignition temperature is to be reached, either it is a dry grass, either or it is any other substance in the forest. When it start to burn, its ignition temperature is to be reached. Okay, so student today, so all friends will stop here, and thank you for all of your patience. Okay, bye.